I'm Josh Haugen.
I'm Jamie Taylor. I'm Eric Schlepper.
My name's Tanner Boss. And this year, we finished up our wirelessly controlled LED light for Senior Design 3.
The idea of our project, we wanted a light source that is remote controlled. You can control where the light is pointing, what color the light is, and how bright the light is. So some of our requirements, we wanted a light that has a full range of motion plugged into the ceiling. It's going to be about the diameter of a CD. The biggest requirement was that the light is plugged into the ceiling in a regular light socket and operates with that. The position, color, and light intensity are all controlled by the remote.
Okay, so this is the LED device flow chart. Starting from the light socket, we come in with 120 volt AC RMS, which is transformed to 6.3 volt. Regulated to 5 volts, the buck regulator, and that powers everything on the device from the Zigbee to the device PIC, and then all tuners and all the LEDs. This is the schematic for the part of the device, which has the transformer coming in, transforming it to a 6.3 volt rectifier bridge, labeled D1 over there, 3 bank capacitors for containing the ripple, and then we've got over here the regulator circuit. This is the microcontroller and Zigbee, as well as all the LED controls in this schematic. The PIC's over there with 2 caps decoupling the power lines. We have the Zigbee talking to the PIC through RC7 pin there. And then we've got 4 FETs that control each color individually and the brightness through pulse width modulation. And we have 2 headers that come in to control the rotate and the tilt motors, which are all through pins RA0 through RA5. And this is the top side of the PCB here with, as you can see, the PIC, the crystal over there, 20 megahertz, and the transformer. And on the bottom side here, the one facing the light itself and the floor are the 3 bank capacitors, the Zigbee, as well as the FET control circuitry for the LEDs.
Okay, so as far as the software goes, the software is also around the PIC there. It sends pulse width modulation through these lines here, goes to these MOSFETs. The MOSFETs turn on, saturated, and then the current dumps through the lights, through the resistors that are for each light, and then we get different colors based on what our pulse width modulation is at. The motors also operate similarly. When the pulse width is wide, we get one of the motors spins one direction. When it's narrow, it spins the other direction. The other motor is, the angle is based on what pulse width we have. So this is the buck regulator on the top side of the device PCB.
Alright, so right here we have the device enclosure modeled in SolidWorks. And so this is a cross section. There's a function that allows it to rotate. And so by rotating it, we're able to have an opening at the top for the connection to the socket. And then on the bottom, we have a lid that will lock into place. And there's a groove, maybe you can see it here, a groove that's 6 millimeters deep. That's for the lid and the connector, which is on the next slide. So here's the lid. As I said, it's 3 millimeters thick. It's not too flexible. It's sturdy enough. It's held into place through the 4 holes, which have the L-shaped connectors that come up through them. These are glued with cyanoacrylate. The holes are drilled that are big enough for a cotter pin to slide through and lock into place. This is a hole that for the hand servo motor, and that's held connected by screws. And this hole is for wires from the tilt servo motor and the LED. And this piece up here connects to the PCB, and so it's not wiggling around inside the device enclosure. So this is the flow chart for the remote. The remote is powered by 3 AAA batteries. They'll sit in a battery pack, and those batteries directly power the Zigbee, which has a voltage regulator on board. And then the batteries also go through a linear regulator, which powers the push buttons for the PIC, and then that goes to the Zigbee as well. Here's just the schematic for the remote. We got the 2620 PIC in there. Got all your push buttons, 12 push buttons, linear regulator, and then on the Zigbee for as well, which goes to the transmit pin on the PIC. Alright, this is a picture of the soldered PCB for the remote. And as you can see, there's 8 buttons up there. That's for the plus or minus pan, tilt, dim, and power cycle. And then these 4 buttons right here are presets. We have white, chartreuse, which is neon green, hot pink, and deep blue. And so this picture shows the bottom of the remote. This Zigbee will transmit, and all of it is powered by 3 AAA batteries.
So software for this PIC. So when you hit a button on the top of the remote, it's going to transmit number 1 through 12. So that button is seen by the PIC, and then it outputs it in 8-bit UART data. So that data line goes to the Zigbee and then shoots across over to our device.
So this is the enclosure for the remote. Once again, it was made in SolidWorks. This hole right here is for the battery pack. There's an on-off switch, so this allows you to easily turn it on and off to conserve the battery life. And then these extrudes right here are to hold that battery pack in place. There's a lid that's sunk in for the lid. There's a lid right here, it's 2 millimeters, and that allows for a snug fit. There's no screws that hold the lid on for the remote. This right here is just to sink in and give the pick a little bit more room.
Okay, so this is the final product here, picture of the device. On the left side, you've got the device all enclosed, and this is what it looks like when you hang in your ceiling. Right here, the top is popped off, and you can see the bottom side of the circuit board. Here is the final product of the remote. Left side is with the top still on, colored gold with all the buttons labeled, and the right side is the top popped off with the top side circuit.
So we have a bill of materials listed on right here. You're granted $485 worth of it. We spent $316 of that. And if you were to add up one component in the device and the remote, if you add them all up, it equals $290. Divide that by 2, and the cost of one unit is about $145. A majority of that comes from the PCB milling and the 3D material. So mass producing this would obviously bring that cost down a lot. Thank you.